Right. So this is one of the questions in the Engine 111 Week 10 quiz. It wants you to find the phase difference between V3 and V1. The first thing to do is get a graphics calculator. With a graphics calculator, it's so much easier. The next thing you want to do is you take your graphics calculator, you go into Run Mat, or number 1, you go Shift Setup, then you go down to Complex Mode, and you set that to R angle theta. What this will do is it will give you all of your answers with a length or a magnitude, and then the angle that is around the center point. Because what we're going to be doing here is we're going to be converting phase differences into complex numbers represented like this, so we can use a calculator on them. Your calculator must also be in radians, because all of the phase differences they give you are radians. As we want to find V3, we have two options. We can find L1 and V2 and add them together, or we can find R1 and V1. I'm going to pick R1 and V1 because V1 has no phase difference, and we're comparing to V1. So the first thing we want to do is we want to get the total voltage over R1 and L1. And this will be V1 minus V2. Because V2 starts positive, that way you can take it away instead of adding. 30, and then shift, and then X, theta, T, and this will get you the angle symbol, allowing you to write a number and then an angle. So we'll put in 230, and then because V1 has no phase difference, it's just 0 degrees, minus 230 angle pi over 4. And then just press enter. That should give you 325.269 blah 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 at an angle of minus pi over 4. This is the total voltage over R1 and L1. Now we have the voltage over R1 and L1. We want to get the total impedance through R1 and L1. We can use the same idea in our calculator by adding complex numbers. So the total impedance, X, will be the resistor, R1, plus the reactance of the inductor. Now, the resistance R1 is 2000 at an angle of 0 degrees. And the reactance of the inductor is going to be 2 pi f, or in this case 100 pi, times the inductance, which is 0.6. And now this is important. If you have an inductor, it'll be at an angle of positive pi over 2. So at a axis, it'll be going up here. If you have a capacitor, it will be minus pi over 2. So it will be going down here. Since we have an inductor, we're going to use positive pi over 2. And when you add these together, the total impedance, is going to be around 2008.86 at an angle of 0.09397. Save this as like B in your calculator. Now we have the voltage over the resistor and the inductor, and we have the impedance. We can find the current. The current is V equals IR, or in this case V equals IX, because it's reactance. So the current flowing through them will just be V over X. And we have V saved as A and X saved as B. So you can just recall that from your calculator and go A over B, which is 1619 something something at an angle of minus 0.879. So this is the current that will be flowing through the resistor and the inductor. What we can do after this is we can multiply this current by the individual value of the resistor to get the voltage over the resistor, or we can multiply by the individual value of the inductor's reactance to get the voltage over the inductor. I'm going to multiply it by the resistance because the resistor has an angle of 0. So we'll do 2000 at an angle of 0 times this, which I saved as C, which is 323.83 at an angle of minus 0.879, still because this is multiplying with no change in angle. Now this is the voltage over the resistor. Now that we have the voltage over the resistor, we have the voltage here, and we have the voltage here because it's given to us, we can simply add these two values. Or in this case, because we have V1 as acting this way, the resistance will be acting the opposite way. So we actually do V1 minus R1, and then that will get us the total from here to here, which is V3. So we take our V1, which is 230 at an angle of 0, minus R1, which is 323.8 at an angle of minus 0.879. And our answer for V3 is 250 at an angle of 1.477. Now, because we're comparing to V1, and V1 has an angle of 0, the difference between these two is 1.477. But if we had V1, say like 2.3, we would have to find the difference between these two. But because this is 0, the phase difference is 1.477. Now, if you get an answer, and it's not any of the possible answers on the quiz, try adding or subtracting 2 pi, because your answer might just be one full rotation off, and it will be the same answer. Thank you.